In the soft hush of your room, as the world settles into a gentle quiet, let us embark on a calming journey, a journey to the quiet symphony that lives within your body, your nervous system. Imagine it as a secret network of whispering wires, weaving a peaceful tapestry of sensation, thought, and motion, all without a single shout or demand for your attention. Your nervous system is like a gentle conductor, orchestrating the endless interplay of signals that keep your heart beating steadily and your breath flowing softly. It listens to the lightest touch, senses the faintest change in temperature, and carries your thoughts and memories like delicate threads in a cozy, infinite quilt. Now, close your eyes and picture this, a vast and intricate web, stretching from the very crown of your head, down the length of your spine, and branching far beyond to the tips of your fingers and toes. This is your personal forest of nerves, quiet and invisible. It manages the dance of your body, guiding every twitch, every flutter, every flicker of feeling. At the heart of this forest lies the central nervous system, your brain and spinal cord, the wise old keepers, calmly deciding when it's time to move, remember, or feel. Sprouting out from them is the peripheral nervous system, like a team of messengers reaching every corner of your body, carrying whispers from the outside world and gentle instructions from your brain out. Sometimes, this system moves so quickly, faster than the quickest blink you can make. When your hand brushes against something hot, before you even realize it, your nervous system has already sent a message rushing back, pulling your hand away safely. It's the silent hero that guards you without asking for thanks. But the nervous system is not just swift, it is also thoughtful. It gently balances the rapid zings with a soft hum of deeper, slower conversations inside you, like clouds slowly drifting across a calm sky. It senses the sadness in a friend's voice, the delicate shifts in your heartbeat when you feel joy or nervousness. You don't have to command it to work. Your nervous system takes care of the many graceful movements and silent thoughts in your life, like a quiet friend who always shows up early, knows your routines, and never forgets the little details. Tonight, as you lie here, feel that soft hum in your body. Each gentle twitch, every steady breath, is the nervous system quietly at work, humming a lullaby that keeps you safe, alive, and connected to all the wonders within and around you. And so, as you drift deeper into rest, imagine the slow dance of these silent messages, weaving your dreams, carrying your memories, and cradling your thoughts gently until morning light. Your nervous system is always whispering, and you are its serene listener. Within your quiet, resting mind, there exists a remarkable community, a crowd of tiny cells, so delicate, so intricate, they carry the very essence of your thoughts, feelings, and memories. These are your neurons, the whispering cells that shape the gentle symphony of your mind. Imagine a neuron not just as a cell, but as a secret messenger, a patient storyteller, softly exchanging ideas with thousands of neighbors. Each neuron is like a unique tree turned sideways. Its branches, the dendrites, reach out like leafy arms, eager to listen, while its long trunk, the axon, stretches far, carrying messages to distant companions. This delicate tree does not shout across a room, but instead exchanges quiet signals that travel rapidly, yet silently, transforming your experience of the world. Your neurons are remarkably social creatures. Picture a barn filled with countless whispering trees, each one connected to thousands of others by tiny pathways. Sometimes, a neuron holds over 10,000 of these connections, forming an intricate network that hums beneath your awareness as you breathe, dream, or simply rest. Yet, despite this closeness, no two neurons ever quite touch. Between them lies a tender gap, a polite space called a synapse, a place where messages leap not as noise, but as chemical whispers shared in confidence. This dance of signals inside your neurons combines tiny electrical sparks, called action potentials, with the chemical language of neurotransmitters. These are special messengers like dopamine, serotonin, or glutamate, each carrying different tones, some encouraging a neuron to speak up, others urging it to hush. When a neuron decides the message is strong enough, it fires with a quiet electrical pulse, much like a line of dominoes toppling gently but swiftly across a polished floor. Wrapped around many of your neurons is a soft insulating blanket called myelin. Think of myelin as a cozy high-speed train track for electrical signals, allowing your messages to travel swiftly and precisely, without losing strength along the way. This insulation is so vital that without it, your thoughts would crawl like molasses, movements would lag, and simple reflexes would grow clumsy. You might wonder, how does a neuron decide when to fire? It's like holding a calm beach just before the tide arrives. When enough gentle waves nudge the shoreline in invitation from the world outside, or a signal from a nearby neighbor, the neuron reaches a tipping point, and suddenly, a wave of excitement races down its length. This moment, called an action potential, is a swift and silent race of ions, charged particles flowing in a delicate tide that moves your mind's messages. But neurons are more than simple messengers. They are adaptable and wise. They can strengthen their friendships, tuning into certain neighbors more deeply as you learn, remember, or grow. Some connections may loosen or fade if not used, much like a garden path that becomes covered in moss when left untrodden. This remarkable flexibility is called neuroplasticity, the nervous system's quiet promise that your brain is never truly finished, always adapting with new experiences, thoughts, and dreams. Sleep, that peaceful harbor of rest, is when many of these neurons quietly rewiring themselves, pruning unnecessary branches and reinforcing others until they form a harmonious melody. Even in stillness, millions of neurons fire in complex patterns, a softly glowing constellation within your skull, laying down memories and shaping your feelings. As you lie here, feeling the gentle rise and fall of your breath, imagine this vast forest of neurons softly murmuring in the background. Each whisper is a thread weaving through your mind, carrying your laughter, worries, hopes, and quiet moments of wonder. Like friends gathered around a campfire under a starlit sky, they share stories that become the fabric of you. Close your eyes now and sense the calm confidence of these whispering cells, working tirelessly in shy harmony. In the quiet between the sparks, your thoughts take shape, your dreams kindle, and the foundation of your being rests on this delicate, extraordinary network, ever whispering, always listening, and gently, as a leaf might settle on a still pond, your mind drifts into a peaceful sleep, cradled by the silent song of your neurons, humming softly through the night. Imagine your nervous system as a masterful storyteller, gathering whispers and images from a rich tapestry of experiences around you. It doesn't simply receive information like a passive receiver. It carefully listens, sorts, and weaves all these quiet signals into the seamless story you call your reality. Tonight, we'll explore how your senses touch, taste, smell, hearing, sight, and the often overlooked sense of body awareness called proprioception form the gateways through which your nervous system paints the vivid world you live in. Let's begin with the sense you may think of most often, touch. Your skin, the largest sensory organ you possess, is a sprawling landscape dotted with specialized receptors. These gentle sentinels detect pressure, vibration, temperature, and even pain. Some receptors are tuned to the whisper-light brush of a feather. Others alert you to the firm grip of a hand or warn you of a dangerously hot pan. When activated, these receptors send electrical impulses along sensory neurons, the messengers carrying urgent updates toward your spinal cord and brain. It's this flow of information that lets you feel the soft wool of a blanket, the chill of evening air, or the prick of a stray thorn. Next, taste invites you to savor the world in a delightful parade of flavors. Tiny structures on your tongue called papillae house countless taste buds, each a cluster of receptor cells eager to detect but 5 simple tastes: sweet, salty, sour, bitter, and umami, the savory richness found in things like soy sauce or grilled meat. These receptors translate dissolved chemicals from your food into electrical signals that journey along nerves to your brain, where they mingle with smells, textures, and even sight to create the full experience of flavor. This is why a cold can dull not just your nose but the joy of your favorite meal. Speaking of smell, your olfactory system holds a special place in the nervous system's heart. Unlike other senses that take a detour through a traffic roundabout called the thalamus, smell bypasses this stop and goes directly to deeply emotional regions of your brain, linking sense to memories and feelings. Hundreds of types of olfactory receptors in your nose detect different odor molecules floated on the air. Together, they create a symphony of scents: fresh-cut grass, rain-soaked earth, baking bread, some so evocative. A single whiff can carry you instantly back to a moment from childhood or long-lost vacations. Hearing is another marvel. Air vibrations funnel through your ear canal, striking the eardrum and setting in motion a beautiful chain of tiny bones, the hammer, anvil, and stirrup. These amplify the sound and send waves into the fluid-filled cochlea, where delicate hair cells dance to the rhythm of pitch and volume. These dances trigger electrical signals that travel to the auditory cortex of your brain, allowing you to recognize the rustling leaves, a whispered secret, or the notes of your favorite song. Vision, often the most commanding sense, captures light itself. Photons slip through the front window of your eye, the cornea and lens, focusing light on the retina at the back. Specialized cells there, rods and cones, turn light into electric impulses. Rods excel in the soft gloom of night, while cones see color in brilliant shades of red, green, and blue. Your brain then deftly assembles these impulses, correcting gaps and blending colors, until the vivid, richly textured scene you see emerges. A fascinating secret: there's a tiny blind spot in each eye, where the optic nerve leaves the retina, yet your brain fills in the missing piece, without you ever noticing, quietly completing the picture. Beyond the classic five senses, there's proprioception, your body's sense of itself. It's the invisible map in your brain that knows where your limbs are, even with your eyes closed. Stretch receptors hidden in muscles and joints keep a constant conversation flowing about how bent, stretched, or relaxed you are. This precious sense lets you touch your nose in the dark, balance on one foot, or walk gracefully without watching your feet. Without it, movement becomes unsteady, uncertain. Together, all these sensory streams flow into neural circuits, the nervous system's bustling networks. Sensory input arrives as raw data, bits of electrical code from specialized receptors. In integration centers like the brain and spinal cord, this data is sifted through with care. Your nervous system weighs relevance, compares current input with memories and expectations, and chooses responses. This filtering lets you ignore the soft thrum of your socks, but quickly turn attention to the sudden chill of cold water. These circuits don't work in isolation. They intertwine, bringing sight and sound, touch and smell, memory and emotion into a continuously coordinated dance. That rustle of wind, the scent of petrichor after a summer rain, the sun warming your skin, all arrive as unified, seamless moments shaped quietly and expertly by your nervous system. They keep you safe, guide your movements, enrich your interactions, and open the door to art, music, and wonder. So tonight, as you rest beneath your blanket, feel the miracle of your senses at work. Every gentle breath you take, every faint sound, every whisper of light and shadow is a silent collaboration within you. Your nervous system is not just a messenger but an artist, painting reality from the brushstrokes of a million tiny signals, all moving softly, swiftly, and invisibly behind your closed eyes. With each sensation, your world unfolds anew, woven thread by glowing thread in the delicate loom of your nervous system. Every movement you make, from the smallest twitch of a finger to the grandest dance, begins not with muscle but with a spark of intention in your brain. This chapter explores the remarkable journey from thought to action, revealing the complex, lightning-fast collaborations within your nervous system that orchestrate every motion with grace, precision, and balance. Movement begins deep inside the frontal lobe of your cerebrum, in a specialized region called the motor cortex. This area doesn't just send random commands, it carefully plans the details: how far to stretch your arm, how much force to apply, which muscles to activate, and exactly when to do it. Before your hand even lifts, the motor cortex has crafted a strategy. Once the plan is set, signals travel down through the brainstem into the spinal cord, along long fibers known as upper motor neurons. Think of these as the executive branch of movement, issuing high-level orders. These commands then pass to the lower motor neurons, nestled in the spinal cord, which send their axons out through the peripheral nervous system to directly connect with muscles. At the point where nerve meets muscle, called the neuromuscular junction, the neuron releases a chemical messenger called ACE. This molecule acts like a green light, binding two receptors on the muscle fibers and triggering a cascade of events inside the muscle cell. Calcium floods into the fibers, proteins shift, and contraction follows. When enough muscle fibers contract together, your hand moves, whether to grab your morning cup of tea or wave hello. The system is remarkably precise and adaptable. Your brain can recruit just a few motor units each, made up of a motor neuron and its muscle fibers, for delicate tasks like threading a needle, or can summon hundreds for heavy lifting. The nervous system fine-tunes activity by controlling how many motor units join in, motor unit recruitment, and how rapidly they fire signals. Rate coding. It's like turning volume up or down on a stereo to get just the right intensity. But movement isn't only about muscle contractions. Precision, timing, and coordination are equally critical, and that's where the cerebellum shines. Sitting at the back of your brain, the cerebellum acts as a graceful conductor. It compares what you intended to do with real-time sensory feedback from your muscles and joints, making split-second adjustments. Without it, motions become awkward or jerky. Imagine reaching for a falling pen and either missing or knocking it over instead. Another key player is the basal ganglia, a set of interconnected brain structures involved in starting, stopping, and smoothing out movements. When this system malfunctions, as in Parkinson's disease, people experience tremors, rigidity, and difficulty initiating actions. Movement planning doesn't happen in isolation either. The prefrontal cortex helps plan motions based on external cues, while the supplementary motor area coordinates internally motivated actions, like standing up. The parietal lobe provides spatial context, helping you know where your limbs are relative to your surroundings. Your nervous system continuously listens as you move. Proprioceptors, sensory receptors in muscles, tendons, and joints send constant updates to your brain about the position and tension of your body. This feedback allows real-time corrections and smooth coordination, even without looking. Your inner ear's vestibular system also contributes by detecting head movements and orientation, aiding balance and spatial awareness. Not all motor commands are conscious. Automatic movements like blinking or adjusting posture happen through brainstem pathways and spinal reflexes, operating quietly behind the scenes to keep you upright and breathing. Emotions influence movement too. Nervousness might tighten muscles. Happiness brings smiles. Fear can cause freezing or fleeing. These effects connect through pathways linking the limbic emotional system with motor areas. Learning new movements, whether yoga poses, ice skating, or chopsticks, is often awkward at first. This reflects your brain building and refining motor circuits through trial and error. Much like rehearsing a play, practice refines these circuits until actions become fluid and automatic, shifting control from conscious planning to more efficient, automatic centers of process, often called muscle memory. Motor control is not flawless. Fatigue, distractions, and aging can slow coordination and reaction times. Yet the nervous system is adaptable, and regular use and training help maintain function well into old age. But movement also rewards you. Physical activity releases brain chemicals like dopamine and endorphins, linked to pleasure, motivation, and even euphoria. So the nervous system doesn't just control motion, it celebrates it. Behind every graceful pirouette, every step, and every wave is a symphony of electrical impulses, feedback, and practiced circuits, all working quietly and rapidly in harmony. This motor magic is the nervous system's gift, turning thoughts into actions that carry you through every moment of life. Neuroplasticity is the brain's remarkable ability to rewire and reshape itself throughout life in response to experience, learning, and even injury. It means your brain is not a fixed structure. It's a living, growing network that adapts like a garden, evolving with care. Your brain contains billions of neurons, each forming thousands of connections called synapses. These connections aren't permanent. They strengthen with use or fade away when neglected, a notion captured by the phrase neurons that fire together, wire together. When two neurons frequently activate together, their link grows stronger, creating faster, more reliable pathways. Conversely, unused pathways are pruned away, clearing mental clutter and improving efficiency. Neuroplasticity supports everything from mastering new skills to forming memories and adjusting habits. When you practice a skill like playing piano or speaking a language, neural circuits involved in those actions become more efficient and tightly connected. Even when you're not consciously learning, your brain maintains and reshapes its networks. Some circuits strengthen through routine use, while others weaken from disuse. This capacity to adapt also extends to healing. After brain injuries like stroke, neuroplasticity allows other areas of the brain to take over lost functions. Rehabilitation therapies focus on training the brain to form new pathways to regain movement, speech, or daily skills. Sensory reorganization is another example, where brain areas deprived of their typical input, such as blindness, are recruited for other senses like touch or hearing. Neuroplasticity isn't uniform across the brain. Certain regions, like the hippocampus, important for forming memories, remain especially flexible, and can even grow new neurons throughout life. Factors like novelty, attention, and emotional importance can boost plasticity, making meaningful or challenging experiences more likely to reshape your brain. Habits form through plasticity too. Repeated behaviors strengthen associated neural pathways, sometimes making actions automatic even if those habits are good or bad. Breaking a habit means creating competing pathways and practicing new behaviors until they become dominant. Emotional experiences also shape neural circuits. Chronic stress can remodel pathways in areas related to fear and decision-making, increasing sensitivity to stress. Fortunately, activities such as mindfulness, therapy, social connection, and good sleep promote healthier brain wiring. Sleep plays a crucial role in neuroplasticity by consolidating memories and strengthening newly formed pathways. During different sleep stages, the brain sorts through the day's information, deciding what to keep and what to discard, much like saving and organizing files. A striking example of plasticity is the phenomenon of phantom limbs. When someone loses a limb, the brain region that processed sensations from that limb is repurposed by neighboring regions, but sometimes the brain still feels the missing limb, a testament to its adaptive but evolving map of the body. Technological advances increasingly harness brain-computer interfaces, neurofeedback, and virtual reality help retrain or enhance neural networks gently through feedback and repetition. Medical research explores gene therapy and stem cells to repair damaged neurons, while synthetic synapses offer future possibilities to augment or replace neural circuits. Yet neuroplasticity often involves patient, sometimes awkward practice and gradual change. It's a quiet, ongoing rewiring beneath your everyday life, soft unfolding of new possibilities that keeps your brain vibrant and resilient at any age. Your brain is never truly finished. It continuously listens, adapts, and rewires itself based on what you do, feel, and pay attention to, quietly sculpting the pathways that make learning, remembering, and even dreaming possible. Neuroplasticity is truly the nervous system's greatest superpower, and ever-present magic quietly shaping who you are and who you can become. Memory is a magical and essential ability that shapes who we are, yet it often works in mysterious, selective, and sometimes imperfect ways. The nervous system doesn't store memories like files in a cabinet or data on a hard drive. Instead, memory lives in patterns of neural activity, strengthened connections, and coordinated chemical changes across networks that are always evolving. Memory can be broadly categorized into three main types. Sensory memory. This is the briefest form, holding raw sensory input for just a few seconds, long enough for the brain to decide if it's worth paying attention to. It's like a fleeting loading screen in your mind where sights, sounds, or touches linger briefly before fading or moving forward. Short-term memory, working memory. This acts as a mental notepad that keeps small amounts of information active for seconds to about a minute. It helps you hold a phone number long enough to dial it or track your place while searching for something. Working memory is flexible, juggling ideas and real-time tasks, but it's highly susceptible to distraction. Long-term memory. This durable archive stores facts, skills, experiences, and emotional associations. Long-term memory divides into explicit memories that you consciously recall, like a historical fact or a favorite story, and implicit memories that influence your skills and habits without conscious thought, like riding a bike or typing. Turning short-term memories into long-term ones requires a process called consolidation, which takes time and often depends on getting good sleep. During sleep, especially deep in REM stages, the brain sorts through daily information, deciding what to keep, what to discard, and where to file important memories to strengthen neural pathways for later retrieval. 1. Crucial brain structure in memory consolidation is the hippocampus. Although it doesn't store long-term memories itself, it acts as a hub that links various elements of an experience, sounds, sights, context, and feelings, so they can be reassembled later. Over time, memories are distributed to different cortical areas depending on their content, such as visual memories near the visual cortex and auditory ones near the auditory cortex. Emotion plays a powerful role in memory. The amygdala, part of the limbic system, assesses emotional significance and boosts memory storage for emotionally charged events. That's why you remember moments of fear, joy, or surprise more vividly than mundane details. However, Memory isn't a perfect recording, it's reconstructive, which means each time you recall a memory, you rebuild it from pieces, not simply retrieve a flawless copy. This makes memories prone to distortion, influenced by new information, current feelings, or even how others tell the story. Selective memory is another key feature. Your brain continuously chooses what to store or discard, often based on relevance, repetition, emotional impact, and context. Forgetting is not a flaw, but a useful mechanism to clear unnecessary clutter and protect you from emotional overwhelm. For example, forgetting where you put your keys often results from a lack of attention during the moment you set them down, not faulty memory storage. You can boost memory effectiveness with simple strategies such as repetition. Revisiting information strengthens connections. Spaced repetition. Reviewing material at increasing intervals is especially good for long-term retention. Chunking. Grouping related bits into meaningful units, like breaking a phone number into parts. Mnemonics. Visualization and storytelling. Making information engaging and emotionally resonant helps it stick. While memory can decline with age, it's not always straightforward. Some types, like general knowledge, remain strong or improve, while others, like working memory, may slow. Thanks to neuroplasticity, the brain continues to form new memories and adapt, especially when stimulated through learning, social interaction, exercise, and good sleep. Even in conditions like Alzheimer's or other dementias where memory fades, emotional memory, the feeling attached to experiences, often remains intact, preserved in deeper brain areas. Memory isn't just storage, it's the thread that connects you to yourself, holding your personal story and identity. In summary, memory is a dynamic, selective, and deeply human process. It evolves with experience and emotion, shaped by complex brain networks quietly working behind the scenes. Every moment you remember, laugh, or pause when something slips your mind, you are witnessing the nuanced dance of your brain's quiet archivist. Emotions are like weather systems within you, sometimes sunny, sometimes stormy, occasionally foggy with a chance of snacks. They drift in, reshape your thoughts, and color everything you perceive, often without asking permission. While feelings may seem fleeting or mysterious, their roots are deeply biological, orchestrated by your nervous system, shaped by evolution, guided by chemical messengers, and played out not just in your brain but throughout your entire body. At the heart of this emotional orchestra lies the limbic system, a collection of brain structures forming a ring around the brainstem, where ancient survival systems meet newer thinking regions. Key players include amygdala, often called the brain's fear center. It does more than sound alarms. It detects threats, assesses emotional importance, and attaches feelings to memories. When startled, a sudden noise or unexpected pop quiz, the amygdala springs into action, triggering a quick internal alarm, sometimes with a little overzealousness that makes you jump at harmless things. Hippocampus. This structure records context where and when emotional events happen, laying down the backdrop so memories can be revisited vividly later. This connection between emotion and memory is why feelings intensify recalling certain moments. Hypothalamus. Sitting below the thalamus, it links the nervous system to the endocrine system. Emotional stimuli trigger the hypothalamus to signal the pituitary gland, which releases hormones into the bloodstream. These hormones raise heart rate, dilate pupils, alter digestion, and create the physical sensations tied to emotion, like anxiety tightening your stomach or joy giving you a bounce in your step. Emotions arise from the balance between two branches of the autonomic nervous system. The sympathetic system prepares your body for fight or flight, feeding up heart rate, redirecting blood flow to muscles, dilating pupils, slowing digestion and evolutionary response to threats or stress. The parasympathetic system brings you back to calm, slowing heart rate, constricting pupils, promoting digestion, and repair a built-in rest and digest system. Most emotions are blends: fear mixed with excitement, sadness tinged with relief, happiness shaded by nostalgia. Your brain doesn't flip a simple switch, it activates multiple regions, compares past experience, reads social cues, and even consults your gut, literally, since the enteric nervous system in your gut communicates closely with the brain. This explains why anxiety can cause stomach upset or why you feel it in your belly. Chemicals called neurotransmitters steer emotional states in various ways. dopamine, associated with reward and motivation, spiking when goals are achieved or enjoyable experiences occur. Serotonin influences mood, sleep, and appetite. Central to many antidepressants, norepinephrine, like adrenaline, it revs up alertness and arousal. Oxytocin, the love hormone, promoting social bonds, trust, and attachment, released during hugging or tender moments. These chemicals interact in a complex dance influenced by genetics, environment, experience, and behavior. Even simple acts like walking in nature, sleeping well, or hearing a favorite song can nudge your emotional chemistry in a new direction. Emotion regulation depends heavily on the prefrontal cortex, the brain's reasoning center. It assesses input from the limbic system, helping calm the amygdala and modulate responses, like deciding whether to panic at a spider or guide it outside. People with strong emotional regulation tend to have a well-connected, active prefrontal cortex. Emotions also underpin empathy. Specialized cells called mirror neurons fire both when you perform an action and when you observe others doing it. They may explain why you flinch when you see someone stub their toe, or feel moved by a character's heartbreak in a film. Social and cultural factors shape how emotions are expressed and understood. Your brain has a universal emotional toolkit, but upbringing, language, and norms fine-tune its use. A smile usually means joy globally, but expressions of grief, anger, or embarrassment vary widely. Naming a complex feeling can sometimes shrink it to a manageable size. Evolution has given emotions powerful functions. Fear protects from danger, anger defends boundaries, sadness signals a need for support, joy reinforces beneficial behaviors, and even guilt encourages social harmony by nudging us to reflect and repair. Emotions aren't just noise, they're critical data, and the nervous system decodes and broadcasts them. When emotional regulation falters, conditions like anxiety, depression, mood swings, or emotional numbness can emerge due to neurotransmitter imbalances, structural brain differences, trauma, or chronic stress. Thankfully, because the nervous system is plastic, therapy, medication, mindfulness, and social connection can help rewire these circuits over time. Even the simple act of slow, deep breathing activates the vagus nerve, a key pathway of the parasympathetic system signaling safety to the brain. This creates a calming feedback loop that lowers heart rate, eases tension, and clears emotional fog, showing that sometimes the most profound nervous system interventions are also the gentlest. Emotions are deeply integrated experiences, not just brain states. They ripple through your skin, chest, breath, and gut. Whether it's affections, warm glow, fears, tight grip, or longing's quiet ache, every feeling is a symphony conducted by your nervous systems, sometimes loud and dramatic, sometimes subtle and slow. Like any symphony, emotions don't just affect the players, they move you, the audience, in profound, unpredictable, and powerfully human ways. Sleep is not just a passive shutdown of your brain, it is one of the most active and mysterious states your nervous system enters. Far from turning off, certain brain areas become even more active during sleep than when awake, but their priorities shift. While you rest, your brain is busy sorting, filing, cleaning, strengthening connections, and dreaming like a housekeeping staff working only after dark. Your sleep cycles last about 90 minutes each, repeating several times per night, and consist of distinct stages within two main categories: non-REM and REM rapid eye movement. Sleep.nan-REM sleep stages. Stage 1. A light, fleeting transition between wakefulness and slumber. Sounds or twitches may still wake you easily. This stage often features hypnic, jerksedan, full body spasms acting like a nervous system. Systems check. Stage 2. A deeper stage where heart rate slows, body temperature drops, and brain waves slow. You become less easily disturbed as the nervous system settles into a low power state, conserving energy and preparing for deeper rest. Stage 3. Slow wave or deep sleep. The most restorative phase where brainwaves slow to large amplitude rolling hills. Muscles fully relax, growth hormone is released, tissues repair, and immune function strengthens. Awakening here often leads to grogginess and disorientation. REM sleep. This phase is associated with vivid dreaming. As your brain revs up, your eyes dart rapidly under closed lids. Breathing becomes irregular, and brainwaves resemble wakefulness. Yet, most muscles are temporarily paralyzed by signals from the brainstem, neurological. Lock to prevent acting out dreams. Dreams remain a scientific puzzle, with theories suggesting roles in emotional processing, memory consolidation, mental rehearsals, or the brain interpreting neural noise into narratives. Beyond dreaming, sleep plays critical roles in memory and learning. Throughout the day, your brain collects new information, storing it in a mental inbox. During deep non-REM and REM stages, the brain reviews this inbox, deciding what to keep, discard, or file. This process is called memory consolidation, which strengthens neural pathways supporting learned information. This is why sufficient sleep after studying or skill practice improves retention. Even brief naps can boost task performance. Sleep also impacts emotional regulation. Sleep-deprived people tend to be more reactive, irritable, and less able to manage stress. The amygdala, emotional alarm system, becomes overly sensitive, while the prefrontal cortex, which normally moderates the amygdala, slows down. Without enough sleep, your brain acts like a cranky toddler. Proper sleep provides an emotional reset, smoothing out daily rough edges and helping you wake more balanced. On a cellular level, sleep activates the brain's lymphatic system, which clears waste products that build up during wakefulness, including proteins linked to diseases like Alzheimer's. Think of it as a nightly rinse cycle for your brain. Though priorities shift, neurons never fully stop working. They maintain vital functions like heartbeat, breathing, and internal balance even in your deepest sleep. Even in dreams, neurons fire across sensory regions, motor planning zones, and emotional centers. The brain doesn't just recall memories, it recombines and plays with them, sometimes creating new connections, potentially underpinning human creativity. Sleep may help us not just remember what happened, but also imagine new possibilities. Despite many insights, sleep remains a biological mystery. Scientists know what happens in different stages and their benefits, but still seek to fully understand why sleep is so essential and why evolution conserved it across species. Intriguingly, dolphins sleep with half their brain at a time. Birds can sleep during flight. Fruit, flies, exhibit sleep-like states. Whatever sleep does, it's crucial, worth lying motionless for hours despite many predators. In humans, the effects of sleep deprivation appear quick. Coordination and memory falter after just one sleepless night. Prolonged deprivation disrupts metabolism, immune function, mood, and even gene expression. Sleep is woven into every aspect of health and cognition. The sleepy brain is not lazy, but a busy, purposeful organ, doing its best maintenance work while you rest. It repairs, sorts, cleans, and creates all, while you dream of penguins, parallel universes, or showing up to work in pajamas. So, when you lie down, think of it not as checking out, but as checking in to a quiet, restorative, neural retreat. Your nervous system knows what to do. All you have to do is drift. The autonomic nervous system, ANS, is the silent, self-governing operator of your body's most vital involuntary functions. It manages essential tasks like heartbeat, blood pressure, breathing, digestion, pupil dilation, body temperature, and sweating, all without conscious thought or effort. This tireless background orchestra continuously tunes and adjusts your body's systems every second, helping keep you alive and balanced. The ANS has two major branches that work like dance partners, taking turns depending on your body's needs. Sympathetic nervous system. This is your inner alarm system, your fight or flight response. When your brain senses danger, a predator, a looming deadline, or an unexpected loud noise, the sympathetic system kicks into high gear. It speeds up your heart, dilates your pupils to let in more light, opens airways for deeper breathing, and diverts blood from digestion toward muscles, readying your body to run or react quickly. It also signals adrenal glands to release adrenaline and norepinephrine, turbocharging your response. Parasympathetic nervous system. Acting as your body's calm counterpart, this rest and digest system restores balance after the storm. It slows your heart rate, constricts pupils to normal size, resumes digestion, encourages relaxation, and supports repair and maintenance functions. It's responsible for energy conservation, immune function, sexual arousal, and digestion. Your nervous system's built-in spa day. A key player in the parasympathetic system is the vagus nerve, a long nerve stretching from the brainstem down through your chest and abdomen. It regulates heart rate, digestion, vocal cords, inflammation, and immune signaling, stimulating this nerve through slow breathing, humming, singing, or cold exposure can reduce stress and improve emotional well-being. Balanced interplay between the sympathetic and parasympathetic systems, called autonomic tone, allows your body to shift seamlessly between readiness and rest. Modern life stress, however, can keep the sympathetic system overly active, causing chronic tension, high blood pressure, and fatigue. Fortunately, behaviors like deep breathing, meditation, stretching, nature walks, and laughter can help tip the balance back toward calm. Some organs experience push-pull control from both systems. The heart speeds up under sympathetic influence and slows under parasympathetic control, while digestion is inhibited by the sympathetic system but stimulated by parasympathetic input. Other organs, like sweat glands, are chiefly managed by one system, sympathetic, explaining why anxiety makes your palms sweat. The autonomic nervous system also plays an important role during sleep. As you drift off, parasympathetic activity rises, slowing heart rate and blood pressure and restoring digestion's gentle rhythm. If awakened suddenly by a noise, bad dream, or bump, the sympathetic system activates almost instantly to bring you alert. Interestingly, the ANS channels emotional expressions throughout your body: blushing, flushed faces during anger, lumps in the throat from sadness, or butterflies in the stomach before an important event, are visceral emotions rooted by autonomic pathways. Your nervous system doesn't just manage your body, it expresses your inner world through it. While disorders of the autonomic nervous system are rare, they can cause symptoms like dizziness, fainting, abnormal heart rates, and trouble regulating temperature or digestion. Conditions such as dysautonomia, orthostatic hypotension, and vasovagal syncope reflect dysfunction in this system. Despite its low profile, the autonomic nervous system functions quietly and flawlessly, maintaining your balance between action and rest, danger and safety, tension and release. It never asks for applause, but deserves a standing ovation for keeping you alive, responsive, and adapting whether you're fleeing imaginary tigers or enjoying a well-earned nap. Myelin is an unsung hero of the nervous system, a fatty, whitish substance that wraps around certain nerve fibers like a cozy high-performance blanket. This insulation ensures that nerve messages travel quickly and precisely, turning flickers of neural intention into rapid actions at the speed of thought. Neurons send electrical impulses called action potentials along long projections called axons. Some axons can be several feet long, like motor neurons running from the spinal cord to the toes. Without myelin, these signals would slow down, lose energy, or leak out, similar to trying to send an unprotected electrical current over a long wire. Myelin acts like the rubber coating on electrical cables, but it's made by specialized glial cells in the central nervous system, brain, and spinal cord. Myelin is produced by Each oligodendrocyte can wrap multiple axon segments from different neurons. In the peripheral nervous system, nerves outside brain and spinal cord, Schwann cells take over, wrapping single axon segments like cinnamon rolls. Schwann cells also assist in nerve regeneration after injury. Myelin doesn't cover axons continuously. It forms segments, separated by tiny gaps called nodes of Ranvier. This structure is deliberate and essential for a process called saltatory conduction, where electrical impulses jump rapidly from node to node, greatly increasing signal speed up to 100 meters per second. This leapfrogging is much faster and more energy efficient than a continuous wave traveling down an unmyelinated axon. Not all axons are myelinated. Those that carry fast, sharp, or long-distance signals such as motor neurons, sensory neurons for touch and proprioception, and many involved in reflex arcs receive this VIP treatment. Axons for slower or more diffuse signals, like many pain fibers, remain unmyelinated or lightly coated, which explains why dull, burning pain arrives after an initial sharp jab. Myelin develops slowly after birth and continues forming well into young adulthood. This gradual myelination process underlies the progressive mastering of skills such as crawling, walking, talking, and complex cognitive abilities. Damage or loss of myelin results in slowed or disrupted neural communication. One prominent example is multiple sclerosis, MS, a chronic condition where the immune system mistakenly attacks myelin in the central nervous system. This degradation can cause muscle weakness, coordination problems, vision issues, fatigue, numbness, and cognitive changes. Symptoms may fluctuate or progressively worsen. The body attempts to repair damaged myelin. with oligodendrocytes sometimes regenerating it in early disease stages. But repeated or extensive damage can injure the axons themselves, causing permanent deficits. Research continues to seek ways to protect, regenerate, or replace myelin to help conditions like MS. Besides MS, other genetic disorders like toxins, vitamin deficiencies, infections, stress, and lack of sleep may impair myelin formation or maintenance. Despite vulnerabilities, myelin is remarkably durable and typically lasts a lifetime, maintained by glial cells that monitor and support nervous system health. Intriguingly, engaging in sustained mental efforts, learning a musical instrument or new language can stimulate increased myelination in relevant brain areas, suggesting myelin is not just insulation but part of the nervous system's optimization process and plasticity. In summary, myelin is essential for the speed, precision, and reliability of neural signals that underpin every thought, movement, and sensation. Without it, your brain and nervous system's remarkable efficiency would grind to a frustrating halt, one sluggish signal at a time.